أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم رب اشرح لي صدري ويسر لي أمري واحلل عقدة من لساني يفقه قولي. Oh my Lord, oh my Creator, expand my chest with confidence, with assurance. Make this task easy for me. Untie the knot from my tongue. Let the words flow easily out of my tongue so that they may understand my speech. Assalamu alaikum wa rahmatullah. Peace be upon you and welcome. Wassce 2008, Paper 1, Objective Questions for Physics. In this paper, we have about 8 questions on physics that involve calculations. There are other questions, of course, relating to physics that are theoretical, and you have to deal with that yourself. So let's try together and attempt to solve those questions that involve calculations. So the questions that involve calculations are a total of 7 number. We've got question 12, question 19, question 23, 40, 46, 52, and the last but not the least, 54. So we are going in that order and then try each after the other, one after the other, and solve them. So without much ado, get your pens, get your papers ready, and let's roll into action. We begin with question number 12, and the question reads, a body of weight 2000 Newton is loaded onto a truck by a machine which lifts it vertically. If the mechanical advantage of the machine is 10, calculate the effort required for this purpose. Objective answers provided. A, 20 Newton. B, 200 Newton. C, 2000 Newton. D, 20,000 Newton. So when it comes to machines, we have what we call the mechanical advantage. For the mechanical advantage, we are looking at the load and then the effort. The load and then the effort. For a machine to do some work for you, you have to put some amount of effort into the machine. And then the machine also work on the load for you. If you don't put in anything into the machine, if you put nothing into the machine cannot be able to perform. So whatever it is that you put into the machine, that is the effort applied. Okay, so you put in the effort, and then the machine will work on the load for you. So when we take the ratio of the load to the effort, that ratio is what you call the mechanical advantage. It shows how efficient your machine is in terms of being able to utilize the energy or the amount of effort that you have put into it, into working or releasing some amount of energy at the other end for you. So the mechanical advantage is the ratio of the load to the effort. The ratio of the load to the effort. The question is seeking something from us. The question wants us to determine the effort that was put into the machine, because the machine has worked on a certain amount of load, 2000 Newton, and the mechanical advantage of the machine is 10. So in order to determine the effort, we have to make the effort the subject of this equation. So our effort becomes the load divided by the mechanical advantage. The load, according to the question, is 2000 Newton, and the mechanical advantage is 10. The mechanical advantage is 10. So dividing the 2000 Newton by the mechanical advantage 10 gives us 200 Newton. Gives us 200 Newton. So mechanical advantage is the ratio of the load to the effort. The load has been given in the question as 2000 and the mechanical advantage provided is 10. What we want to solve for is the effort. So when we come to the formula, mechanical advantage is load over effort, we make the effort the subject of the equation, and then we substitute our values into the equation, and then we arrive at the answer, 200 Newton. When we go through the possible answers provided, possible answer B is 200 Newton. So the answer for this particular question is objective answer B. Okay, so let's move to the next question. Question number 19. The question reads, the weight of an object is 24 Newton on the earth. Determine its weight on the moon if gravitational acceleration on the moon is equal to 1/6 the gravitational acceleration on earth. Possible answers provided. Objective answer A 0.25 Newton, B 2.80 Newton, C 4.00 Newton, and then D 18.00 Newton. So let's attempt the question together. Now, weight is the mass of an object multiplied by the gravitational acceleration. Now, the gravitational acceleration on the earth and that of the moon are not the same. They are very different. The gravitational acceleration on the earth is much bigger than the gravitational acceleration on the moon. After all, the earth is much bigger than the moon. So the bigger the body, the higher the gravitational acceleration. So if you go into the solar system and you have different planets, the sizes of the planets are not the same, and therefore the acceleration due to gravities that they have respectively will not be the same. Now, the earth has one moon which revolves around it, and the moon also has its own gravitational acceleration. The gravitational acceleration of the moon is very small. It is 1/6 that of the earth. In order to be able to determine the weight of an object on the moon, we must determine its mass. Not its weight, its mass. We must find its mass. And then we must find the gravitational acceleration on the moon. And then we multiply the mass of the object and then the gravitational acceleration on the moon. They will find its weight on the moon. That is what the question is trying to demand from us. Or that's what the question is demanding actually from us. So let's find the mass of the object on Earth. So the mass of the object, weight over gravity. The weight of the object according to the question is 24 Newton on Earth. Gravitational acceleration on Earth, remember, is a constant, approximately 10 meters per second square. So this will give us 2.4 kilogram. 2.4 kilogram. So this is the mass of the object on the Earth. On the Earth. The gravitational acceleration of the moon is 1/6 that of the Earth. So G moon is 1/6 that of the Earth. So that of the Earth is 10 meters per second square. So that will give us 1.67 meters per second square. So the gravitational acceleration of the moon is 1.67 meters per second square. If you compare to that of the Earth, you can see that they are very, very different. The Earth's gravitational acceleration is 10 meters per second square. And look at that of the moon, less than 2 meters per second square compared to that of the Earth. Okay, so we expect the weight of the object on the moon to be small compared to the weight of that same object on the Earth. So the weight of the object on the moon is the mass of the object multiplied by the gravitational acceleration on the moon. The mass of the object is 2.4 kilogram and then the gravitational acceleration on the moon 1.67, and this will give us 4.00 Newton. So when we go through the possible answers, objective answer C and tallies with our answer. So the mass of an object is always a constant, whether it is on Earth, on the moon, on Saturn, on Neptune, on Uranus, whatever the heavenly body that we are considering, the mass of the object is a constant. It doesn't change. Even on the Earth, different locations on the Earth, the mass is going to be a constant. But the weight can vary slightly, because even on the same Earth, depending on the locations, the acceleration due to gravity can vary a little. But on the average, 9.82 meters per second square. When we take an object that has a mass of 2.4 kilograms to the moon, to Mars, to Neptune, to Uranus, the mass will be a constant. No doubt about that. But because they have different acceleration due to gravity, because they have different values, the weight of that same object on the different planets will be different. That's why we say mass is constant, weight varies depending on where the object is. Depending on where the object is. So it shouldn't be surprising, even on the Earth, to weigh an object at a certain location on the Earth and get a certain value, and weigh that same object at a very different location on the same Earth and get a value that is slightly different from the first. Slightly, very small change. It shouldn't be surprising, because different locations may have slight difference in acceleration due to gravities, and that will affect the weight. So objective answer C, 4.00 Newton, is the correct answer for question number 19. Let's now move to question number 20. Question number 23 reads, calculate the final steady temperature obtained when 6.0 grams of water at 50 degrees Celsius is mixed with 3.0 grams of water at 40 degrees Celsius. Specific heat capacity of water is 4,200 joules per kilogram per Kelvin. The objective answers provided are A, 10.0 degrees Celsius, B, 45.0 degrees Celsius, C, 46.7 degrees Celsius, and D, 90.0 degrees Celsius. So this is the question. Now this is about heat. Assuming you wanted to bath in the morning, the weather is cold, so you decided to heat some water because the cold water is not suitable for you. Now if you've heated some water in a container and you pour that hot water into a bucket, now the water in the bucket is now a mixture of two waters: the hot water that you've boiled and the cold water that was in the bucket. So you now have a mixture. So that mixture will have a temperature, and that final steady temperature is what the question is demanding from us. That final temperature. The temperature of the hot water in the bucket now, that temperature of the hot water will drop. The temperature of the cold water in the bucket will now what? Rise. And we are going to have a steady temperature, a common temperature now in the bucket. So that is what the question is demanding from us. We should calculate the temperature of that mixture, that water that is now suitable for bathing or whatever. We should determine that temperature. Now let's remember that in heat transfer, when heat is given out, heat is also absorbed by the other substance or substances or objects. So if the hot water is giving out the heat, the cold water will be taking in the heat. Now the question is assuming that no heat is lost to the bucket and no heat is lost to the surrounding air, because in real life situation, the heat that has been delivered by the hot water will be absorbed by the cold water. Some will be absorbed by the bucket, and some will be absorbed by the air. The question didn't make mention of the bucket and the air. So it's an assumption that all the heat that was released by the hot water was all absorbed by the cold water. The bucket and the air did not absorb any of the heat released by the hot water. So all heat released by hot water is equal to all the heat absorbed by the cold water. Period. No heat absorbed by bucket, no heat absorbed by the air. So let's speed into action. So heat given out equals heat in. The hot water is giving out the heat, the cold water is absorbing the heat. Now let's remember our formula when we were dealing with the heat capacity and specific capacity in the other video. We have a formula that we use to calculate the heat absorbed or released when there's heat transfer. So the heat given out by the hot water equals mass of hot water, specific capacity of hot water, and then the temperature change. Remember, the temperature change, the hot water is at a certain high temperature. Now, after mixing it with the cold water, its temperature will drop to a new temperature. That will be the temperature of the mixture. So, temperature of hot water minus the temperature of the mixture now. This is equal to the heat absorbed by the cold water. The cold water now takes in the heat that has been released by the hot water. So, the heat absorbed by the cold water, mass of cold water, specific capacity of cold water, and then the temperature change. Remember, the temperature of the cold water will now rise. The cold water used to be at a low temperature. And now that the hot water has been poured into the cold water, we expect the temperature of the cold water to what? To rise from a lower value to a higher value. And that higher value now is the temperature of the mixture. So temperature of the mixture minus the temperature of the cold water. So this is where we are. If we are able to establish this, then we are almost halfway through. Right? Okay. Now, the specific capacity is a constant for water. Whether the water is hot or the water is cold, the specific capacity does not change. It's a constant. And you can see that it appears on both sides of the equation. For the hot water, there's specific capacity. For the cold water, there's specific capacity. To make things easy and simple for us, what do? We cancel them out. So this is out and this is out. Okay. Mass of hot water. The mass of the hot water is 6.0 grams. And then we have temperature of hot water. Temperature of hot water is 50 degrees Celsius minus the temperature of the mixture now. This is equal to the mass of the cold water, which is 3.0 grams. Temperature of mixture minus temperature of cold water. The temperature of cold water is 40 degrees Celsius. So we move on to the next thing. 6.0 times 50, that will give us 300.0. 6.0 times Tm, 6.0 Tm, 3.0 times Tm, 3.0 Tm, minus 3.0 times 40, that will give us 120.0. Okay, so next stage, let's put all the like terms together. Okay, let's group the like terms. We have 300.0 plus 120.0. This equals 3.0 Tm plus 6.0 Tm. So this is where we are. This gives us 420.0 equals 9.0 Tm. We want to solve for Tm. So we divide both sides by 9.0. So we have over 9.0 over 9.0. So 9.0 cancels 9.0. So our Tm, which is the temperature of the mixture, 420.0 divided by 9.0, and that will give us 46.7 degrees Celsius. So this is the temperature of the mixture now. So that's the final steady temperature obtained. If we mix 6.0 grams of water at 50 degrees Celsius to 3.0 grams of water at 40, This will be the final steady temperature of the mixture that we are going to have at the end of the day. So the objective answer 46.7. Let's go through: A 10.0, B 45.0, C 46.7, and D 90.0. So our objective answer, the correct one, is C, 46.7 degrees Celsius. So this is the correct answer to the question. Let's move on to the next question. Question number 40. And the question reads: calculate the work done when a force of 100 Newton is used to push a trolley of equipment through a distance of 8 meters. Through a distance of 8 meters. So we are supposed to calculate the work that is done. The force has been provided, or the effort has been provided, and the distance has also been given to us. We should calculate the work that is done. This should be a pretty much a straightforward one. So work done. Force times distance, right? The force given to us 100 Newton and the distance 8 meters. This gives us 100 times 8, which is 800.0. So this is the work that is done. Objective answer D is the correct answer to this particular question. This one is just a walk in the park. Okay, so let's move on to the next question. Question number 46 reads: a body of mass 3.0 kilogram moves on a smooth horizontal surface with uniform acceleration of 15 meters per second square. If it covers a distance of 20 meters in 5 seconds, calculate the power of the body. Calculate the power of the body. Anytime an object is doing some amount of work, of course, it generates some amount of power. Now, this object is in motion. The object is moving. So far as it is in motion, it is doing some amount of work, or work is being done. Therefore, power is being generated. We are expected to determine or to calculate the power that this moving object has generated as a result of this motion that is performing, based on the characteristics or values that have been provided in terms of its motion. So to do that, first we must be able to find the work that the object has been able to do. If we're able to determine the work that the object has done, then dividing that amount of work by the time taken to do the work will give you the power generated, because the power is the rate of doing work. The total amount of work that has been done divided by the time used to do the work give you the power. Okay, so we start with calculating the work that the object has done. So the work done by the object is the force times the distance, but the force that this object is generating is its mass multiplied by the acceleration. Is the mass multiplied by the acceleration. Now, substituting that into the formula for work, that will give us work equals mass acceleration distance. We are substituting the MA into the first equation in place of the force, the F. The mass is 3.0 kilograms. Acceleration that the object is undergoing 50 meters per second square, and the total distance covered by the object is 20 meters. So this will give us 900.0 joule. So this is the work that the object has been able to do, covering a distance of 20 meters with an acceleration of 50 meters per second square and having a mass of 3.0 kilograms. So this is the work that the object has been able to do. Now the power generated by the object, work done divided by the time taken to do the work. So that gives us 900.0 joule divided by the time taken to do the work, which is the 5 seconds. So divided by the 5 seconds, 180.0 watts. 180.0 watts as the power generated by the object. So going through the objective answers, A 11.3 watts, B 20.0 watts, C 180.0 watts, and then D 500.0 watts. Our answer therefore is objective answer C, 180.0 watts. 180.0 watts is the power generated by the body undergoing this particular motion. Okay, so we move to the next question. Question number 52. Calculate the frequency of sound wave of wavelength 0.4 meters moving at a speed of 8.0 meters per second. Calculate the frequency of sound wave of wavelength 0.4 meter and moving at a speed of 8.0 meters per second. The wave. So looking at the wave, it has wavelength. So when we take this point to that point, so we have crests and then we have troughs. So we have crest and troughs. Now, if we take these 2 points, the distance between them is the wavelength. Okay. Now, when we look at this portion and we look at this particular portion of the wave, if we take the top part and then we remove this down part, you see, it's like it has made something like a complete circle. So the number of complete circles that it's able to make in a second will give us the frequency of this particular wave, so to speak. The speed of our wavelength C is equal to frequency times the wavelength. This implies that our frequency is the speed of the wave divided by its wavelength. The speed of the wave is 8.0 meters per second and the wavelength is 0.4 of a meter. So dividing that will give us 20 per second, which is equal to 20 hertz. Going through the possible answers, 0.05 objective answer A, B 0.50, C 3.2 hertz, and then D 20.00 hertz. So our correct answer in this case is objective answer D, 20.00 hertz. 20.00 hertz. Now let's move to the last question. Question number 54. A boy stands 2 meters in front of a plane mirror. What is the distance between him and his image? A boy stands 2 meters in front of a plane mirror. What is the distance between him and his image? So you stand in front of a plane mirror or a dressing mirror and you see yourself in the mirror. You are at a certain distance from the mirror. The distance between the mirror and you is the object distance. You are the object. So the distance between you and the mirror is the object distance, denoted by U. The distance between your image that you are looking at and the mirror is the image distance, denoted by V. So object distance U, image distance is V. Now you have a plane mirror and you are standing in front of the plane mirror. The distance between you and the mirror is 2 meters, and that is U, the object distance. Your image will be formed behind the mirror. Your image will be formed behind the mirror. So the rays of light from you will intersect in the mirror, right? So we are going to have your image formed behind the mirror. The distance between the image and the mirror is the image distance, V, and that is also going to be equal to 2 meters. We are supposed to find the distance, this is what we are looking at, we are looking for. This distance is the distance we are expected to calculate. So if you look at the distance very well, it is going to be U plus V, which is 2 meters plus 2 meters, giving us 4 meters. So the distance between the object and the image is 4 meters. That is what we are expected to find. So going through the possible answers, objective answer A 0.2, B 0.4, C 2.0, and then D 4.0 meters. So the correct answer is objective answer D 4.0 meters. So ladies and gentlemen, students and folks, this brings us to the end of this exercise. Remember, like, comment, share, follow, and let's keep learning. Okay, let's encourage our students to have some time for the book so that at least we know that the future is going to be bright. Until I see you in the next video, remember, take care of yourselves and each other.